Hi guys, today we're going to be learning about factor by grouping. So your essential question for today is, does it matter which two terms I take the GCF from? Your first step is going to be the polynomial. Make sure that the polynomial is simplified and written in standard form. The second step is going to identify the GCF of the first two terms. Third step is going to identify the GCF of the last two terms. Fourth step is, if you factored correctly, the two factors in the parentheses should actually be the same, and this is going to be one of your factors, only representing one because it's the same. Your fifth step is going to be the GCFs are the actual other factor, so I'll be showing you guys all this because we're writing it down first. And then your last step, double check that each factor is factored completely and that there's nothing else in common in those parentheses. So for our first example, we're going to go through, and so you are going to use factor by grouping. Anytime you are given four terms is when you are going to use factor by grouping. So anytime four terms. So my first two terms I have here were in standard form because I have the highest exponent going down to the lowest exponent. We can see that. So the greatest common factor I have with my numbers is going to be 3. And then the value that I have for, let me write this better, and then I also have n cubed here and n squared on my second term. So I'm going to take out the lowest value of those n's, and then I have to write my remainder in the parentheses. So we're going to have a 3 divided by 3 is just 1, n cubed divided by n squared is just n, 6 divided by 3 is 2, and then n squared divided by n squared is just 1, and 1 times 2 is 2. Now I'm going to take the GCF of my last two terms. This is our next step. So I have a negative in front of that n, that highest coefficient there is a negative. So I am going to take out a negative 8, and I'm going to write in the parentheses of what I have. I don't get to take out an n because this term actually does not have an n. So now when I do negative 8 divided by negative 8, that's a positive n, and then negative 16 divided by a negative 8, which is a positive 2. So on our steps, when I was showing you guys this, you can see that I said when we have, when our factors, we don't really factor correctly if the things in the parentheses are the same. So we want to double check that the thing in the parentheses is actually the same, and it is, so that's actually one of our factors. In the next step, I said that the next thing, the GCFs, the actual values that we took out, the GCFs of the first two terms and the GCF of the last two terms, that's actually our next factor. So we have a 3n squared minus 8. We want to double check those parentheses to make sure that we don't have anything else in common. So I see that n and 2, we don't have anything else in common with those. A 3 and an 8 definitely don't have anything in common. That n squared doesn't have any n's with that 8. So this actually is our final solution for this example. Okay, so our next example, we have four terms again, so that means we're going to be doing factor by grouping. Our first step is to make sure that we have it in standard form and it's simplified completely. So again, we have our 3, 2, 1, and then 0 term. So we are in standard form. So I'm now going to take the GCF of the first two terms. I see that I have a 4 and an 8, so I know that 4 is the numerical GCF value. And then n cubed and n squared, which means I have n squared as my variable GCF. Now I'm going to write the remainder. So again, this is just the GCFs here. I'm going to write the remainder. So 4 divided by 4 is 1. N cubed divided by n squared is just n. 8 divided by 4 is 2. And then n squared divided by n squared is just 1. Here I have the negative 8n minus 16. So negative 8 happens to be the GCF in this case. And then negative 8 divided by negative 8 is a positive. I have an n left over. Negative 16 divided by negative 8 is a positive 2. So again, I know I factored by grouped correctly because I was left over with n plus 2 in both of my parentheses, and that means I am correct. So that's one of my factors. make sure you use the GCFs as your other factors. So that's why it's important that you're writing these negatives and positive signs so you know which sign to put right here. So then our last step, we want to double check that we have factored completely. So I have n plus 2, again there's nothing in common, but here I see I have a 4 and an 8. So I do know that I can actually factor a 4 out. So I'm going to bring that 4 all the way out in front because this is all multiplication. It actually is okay to be doing that. It wouldn't matter. So I'm going to divide the 4 by 4, so I'm left with an n squared now. And then I have, negative 8 divided by 4 is a negative 2. So now I can double check n squared minus 2. Now those definitely don't have anything else in common, so this is my factored form for my polynomial. For my next example, we are going to go through 12x cubed minus 9x squared plus 4x minus 3. Again, are we in standard form? Yes, we are. 3, 2, 1, 0. So I'm going to take the GCF of my first two terms, 12 and 9. So I know that 3 is actually the GCF of the numerical value for that. And then I know that, let me rewrite that again, sorry. And then I know that the x cubed, x squared, so that means I have an x squared. You always take out the lowest value there. And then we want to actually take it, divide it out. So 12 divided by 3 is 4. X cubed divided by x squared is x. Negative 3 divided by 3 is negative 3. And then we see that I actually already have, do you see how this is already 4x minus 3? Well, look at this is actually 4x minus 3. 4 and negative 3 definitely don't have any numbers in common, it's just 1. But remember we said earlier, a GCF of 1 is actually, we don't take anything out, which means that we can actually just write right here that, so anytime you're not going to take a full-on GCF out means that it won't have an effect on it. So what we're seeing here is that if you take that plus 1 out, that's going to help us though determine our actual factors. So I'm going to write our GCFs 3x squared plus 1. Since this actually, we don't need to change this thing, we're just going to write our remainder. We don't need to change this value. I'm trying to squeeze it in here. Okay, so now we see that 4x minus 3, they are the same, so this is a factor. So if you guys have been noticing on the last few examples, I wrote 4x minus 3 over here, but that is okay. You guys can change them, just like 4 times 3 is 12, but if you rewrite this as 3 times 4, it still equals 12. So these can be interchanged as well, it actually doesn't matter. For that, so just double check that we don't have anything else in common. So 3x squared plus 1. Again, that tricky part, you guys, was just that there was nothing actually here. There was just that 1. It's kind of weird, the factor by grouping, we do have to say, oh, by the way, there's a plus 1 there. We just didn't take anything out, but there is still a term there, so that's why that plus 1 is kind of like a placeholder for it. So that's why it comes into place here. All right, and that's it for today.